Hello students, in this lecture video I will demonstrate how to use SAS Enterprise Miner for creating new project and exploring data. So this is the data set I'll be using called NN underscore response RESP underscore data. It's a hypothetical auto insurance company that wants to acquire the customer through direct mail, and company wants to minimize the mailing cost by targeting only the most responsive customers. And you can read the detail here. It has a target variable called RESP response, which is binary, which takes 0 or 1, one of the two values here. And this data set has many other input variables called age, income, gender, residence type, multi-family dwelling unit, which is uh, which is shown by MFDU, then credit score, marital status, along with many others. So let's go ahead and create a SAS Enterprise Miner project and explore the data set. So I will launch the Enterprise Miner. Click on New Project. Click on Next. See, this is response model. That's the name of my project here. You can give any name you wish. This will take maybe 20 to 30 seconds. Click Next here. Click Finish here. So the first thing we have to do is we have to run our library name command so that we can access our data set. So I will click here. This command will be provided by me. That's a command we have to run here. And here you have to say run now, and once it's done say OK here. So you just ran that command and now you should be able to access the data set. So we'll right click on here, create data source. So we have to go to my data set here. This time we'll be dealing with this particular data set here. So click OK here, click next here. So it has around 18 variables and 29,904 records. So here you have to set the measurement labels and roles for each variable, and it's often best advised to use advanced options so that you can customize the way you want them to be incorporated in your model. So here you have class labels count threshold 20, which means that if you have a numeric variable and it has less than equal to 20 distinct value, that should be treated as nominal. And if you have a numeric value that has more than 20 distinct value, that will be treated as interval. And so we're just gonna say, let's say mention it 10 here. So this reject labels count threshold is for categorical data. So if you have a categorical data that has more than 20 distinct values, you are basically saying that reject those variables. So we're not gonna touch that one here. Just say okay here, next here. So here you can uh, analyze your variables and the roles they're gonna play in the model. So you see that, if you click on basic here, basically you can, I will just drag this one here so that we can compare side by side. So basic type was numeric. Let's say for this one, income particularly, it was numeric, but instead of assigning the label of interval, the SAS chose to assign it nominal. And the reason for that is, if you go to, let's say, statistics here and see the number of labels you have in income, see it has 8 uh, distinct values. Oh, I'm sorry, number of labels 7. So it has 7 distinct values, and our cutoff was 10. So anything that is less than equal to 10 will be assigned nominal. So if you want this to be assigned interval, you can change it here, and you should change it here. Let's say this income is interval, and here this one should be treated as target. That's our target variable, and this binary, it is binary in nature, so it takes 0 or 1, and that is also a part of what we call categorical data or a nominal data. So it's binary here. You can also see some other statistics when you click on, let's say I'm going to get rid of this basic, and I will select the statistics here, so I can see wherever you see number of labels, those are categorical variables. Wherever you see dot, those are numeric variables. So for any numeric variable, you will see minimum, maximum, mean, standard deviation. And for the categorical variable, you will see number of distinct values they have in the data set. So with this, I will click on next here. Just I'm going back here. Remember, this is one of the most important step when setting up your model. So you have to be very careful here defining the role and the label for each variable, because this will tremendously affect your model building and the accuracy of the prediction. So with this, click next here. Let's say this time I want to set up the decision values for the decision. Because our target was binary, it can take 0 or 1. SAS is asking us, do we want to set up the decision or the values for the decision? So let's say yes here, say next here. So here I can set the prior probabilities, decisions, and decision weights. So I will start with the decision weights here. Let's say here I will mention 10 here, and here -1. Now what it means is, if we send the mail to the person, and if the person responds, we make $10 as profit. If we send the mail to the person and the person doesn't respond, we lose $1, because that's our mailing cost. So that's kind of loss. And if we do not send the mail, we don't incur any cost. So I'm just going to mention 0 here. So this is our kind of profit matrix, and we want to maximize the profit here. And since we already set up the profit matrix, if you go to the decisions here, this is basically asking you to set up the cost. But since we are maximizing the profit, we don't want to set it up here. We don't need to. But here at decision weights, if you have chosen minimize cost, then maybe you would like to come here and set up the cost variable. So in this case, I will just ignore this one, go to the prior probabilities here. Now this tells you the distribution of your data. So out of 29,000 something records you have, 9,379 were responders and 20,525 were non-responders. Keep in mind, these are the probabilities that they have. So right now 31% were responders and 68% were non-responders. But these, let's say, these are not the actual representation of the data in the original data set. Let's say I will click here, yes, I want to set up the adjusted prior probabilities, and let's say in the original data set we only had 3% responders and 97% non-responders. So when you mention this adjusted prior probabilities here, SAS will adjust the model accordingly and your prediction will be more reliable. So with this I will select next here, next here, next here, finish. So we just created a data source here. So if you expand it, you'll see it here, and you can see here it has 18 variables, 29,904 records. So let's go ahead and create our first process diagram here. So I will right click on the diagram, create diagram. Let's say this is response model, and then I will drag this data source here. So that's our input node here, and if you click here you can see all the different properties here, number of observation, number of columns. Let's say I want to explore this data set and I want to let's say use some of these nodes here. Let's say I want to use graph explorer, I want to use multiplot node, and I want to use stat explorer. Now remember, I'm in the explore tab here, and then I'm gonna draw the lines to connect these nodes, and you can rearrange these nodes the way you want it. Let me run this stat explorer here. So I will right click on it, run this one. Before I move on here, we need to set some properties here. I'll say no here. Let's say we are dealing with categorical response variable which takes only two values, 0 and 1. So it's categorical. So for categorical variables you often want to have chi-square statistics. So here we do have a lot of input variables which are numeric. So if I want to calculate the chi-square statistics for my numerical variables, I need to mention that here that I do want that. And the way it works is chi-square statistics is basically used to find the strength of association between two categorical variable. It is very much like a correlation analysis, but correlation is more for the strength of relationship between two numerical data or numerical variables. But chi-square is basically used for categorical data. So when you have two categorical data and you want to find the strength of association with them, you use chi-square statistics here. And often one of those categorical variable might be actually interval variable like age, but we need to convert that age into from numerical or interval scale to categorical scale. And the way we do that is by creating bins. That's why we are saying that we're going to create 5 bins so that we can convert that ratio or interval scale to basically categorical scale. So make sure you do that, and then you run this one here. Click on results. So here you see the chi-square statistics for various input uh, variables here versus our response target. So if you see that this resident types has the highest chi-square value, which means this is the one that is strongly associated with our response variable, and then multi-family dwelling unit, and then other variables. So you see the age here is being converted into categorical data by binning, by creating 5 bins. And if you see, the strength is not as much compared to other one. So in your model, looks like these 4 variables or 5 variables will play major role. So this is how you should interpret this data here. So I will close this window here. I will run the second one, multi-plot here. So you see the results here for, let's say, you can select any variable that you want to explore here, the graph. So these are the, let's say we are looking at the age here. So you can see that this is the frequency distribution for the age. We could have, instead of frequency, we can or could have mentioned the percentage. So let's do that. This is the frequency. For example, if you see this one here, this 28 years of age, you see around, there were around 1700 like total data points, out of which maybe around 1150 were uh, blue means I can go here, say non-responders, and red means responders. But let's convert that frequency into percentage. So basically I have to run that multi-plot mode or node again. So I will close this one here. Here multi-plot, select this one and say instead of frequency here you want percentage, and rerun this one. So now instead of frequency you will see percentage, the data in terms of percentage. Click on results here. So it's the same information that we saw earlier, but this time it is in terms of percentage. So here if you see this node here, 28 years, 28.5 years, that data point has around this, like there are total around 5.8% data points in the data set, out of which you can say that around 3.8 or 9% are non-responders and rest are responders. So you can see that most of the data points falls between the age of 25 to around 73, and there are very few data points after 75. So that's the thing you have to keep in mind here. So you can explore this one. Another one you can say that, let's say residence type, that could be another interesting graph to look at. So you can see here resident types could be condo, corporate housing, home, renters. So that's a renting type. Blue means non-responders, red means responders. So if you see, most of the most predominant uh, data points you have in the data set are homeowners. But in homeowners, mostly you have around, most of them are non-responders. So you can see the length of this bar here, and very few are responders. While if you see the renter here, you can see that it's virtually 50-50. So that means if you target renters, you might get more, the probability will be more that they will accept your coupons or mailing solicitation. So that's the way you have to interpret this data here, and you can go through many different graphs here. So with this I will close this one here, and I will run the next one, graph explorer. Right click on it, click on run. See, yes, here. click on results here. So here we see the frequency distribution for our response variable. So again, this is coming from a sample. So this is not the total data set. This is sample data set. So I guess we can always go back and set that thing, that how much records we want to fetch, but let's not worry about it. I will show you that once I'm done with this one. But here you can see that we have more non-responders and less responders, around 2000 responders and 4000 non-responders. You can also change this one. Right click on it here and go to data option. Again, data option here, and here we have to, let's say we want to explore the gender. So gender I will put as a category here, and response type or response, that's our variable, I'll put that as response. So and instead of sum, let's say I want to see the mean. So these are the mean of gender variable versus response. So you see that the basically tells you that male tends to respond more than the female, so because their mean values are higher. So this is the way you have to explore your data. This is very much like data visualization, where you're trying to find the meaning out of the data. And likewise that you can do many other plots. If you go to view plots here, you can explore a lot of these plots here and see what the data really means. So this is a very crucial step here, because this will help you understand your data, and accordingly you can build a very powerful model which can show you very good results, very accurate results. So if you close here, basically you see here we have we had only 2000 or 4000 data points out of the total. So if you close this one here and you go here, that's where this data set is being set. If you click on Graph Explorer here, you see that we are only fetching first and default, and this is the only number of records we are fetching. We can always change this one. We can always say that, fetch random and fetch maximum. Okay, so it's gonna fetch all of them if you want to do that. So you have to keep that in mind. So these are the different ways you can explore the data once you create the data source. And you should do this because this will help you understand your data, and based on this you can build very powerful predictive models. So with this I'll stop my lecture video here. Thank you very much for listening.